Hey guys, I'm making this video series for VTU M3 students, and if you're 21 scheme students, then you will be writing the exam for the first time, 21 or 31, and for 18 scheme students who have M3 backlog. And if you like these videos, please subscribe to our channel and share these videos with your classmates and friends so that it will help them also. Okay, so the question is, find the Laplace transform of e power minus 4t times t power minus 5 by 2. So we have product of two t functions here. So we need to use properties of Laplace transform, okay, because we don't have anything similar to this in the list of or the table of Laplace transform. So what is the property? So if you have e power at into f of t, any function of t here, it can be t power something, sine or cos or anything, okay. So if you have something like this, then taking Laplace transform is, first you need to find the Laplace transform of f of t, which is f of s, right? And then replace s in this with s minus a, where a is the coefficient of t in the e power at. That is the property. That is the property number 1. Okay. So if you compare these two, what is f of t? F of t is t power minus 5 by 2. T power something, some n. Okay. And what is a? If you compare these two, a is minus 4. So you have to replace s with s minus minus 4. One minus is from here, another minus is from here. Okay, don't get confused. So we have to replace s with s plus 4. First find f of s here. Taking Laplace transform of this will give me f of s. Okay, and then replace s with s plus 4. So what is f of s? So we have t power n here. So we know Laplace transform of t power n is n plus 1, gamma of n plus 1 by s power n plus 1. Okay, or this is also equals to n factorial by s power n plus 1. Gamma of n plus 1 is equal to n factorial when n belongs to positive integers. So if n is positive integers, then gamma of n plus 1 is equal to n factorial. If n is something like fraction and negative here, okay, so then you need to then the Laplace transform of t power n is gamma of n plus 1 by s power n plus 1. So here n is minus 5 by 2. N is minus 5 by 2. So that is minus 5 by 2 plus 1 gamma by s power minus 5 by 2 plus 1. Okay. So what is the value of the numerator? What is the value of gamma of minus 5 by 2? Okay. So that we have to find. Okay. We cannot just substitute s as s plus 4 here. Okay. First we need to find gamma of f. So one more step if I do here, what will happen? Minus 5 by 2 plus 1 is minus 3 by 2 s power minus 3 by 2. We need to find the gamma of minus 3 by 2. So what should we know about gamma function? It's an integral again that you will learn in the next module or something like that. But for now, think of it as an operator, like log operator. But log values you can find in calculator, but gamma values you have to find them manually like this. So first thing you need to know is gamma of 1 by 2 is square root of pi, and then whatever value it is here inside, you have to get this to gamma of 1 by 2. How do you do that? Another formula you have to use. Okay. So if gamma of n plus 1 is n into gamma of n, okay, if n is greater than 0, if you use this formula, suppose if you have 5 by 2, it will reduce to 3 by 2 here, it will reduce to 1 by 2 again, okay. But you have negative values here, so then gamma of minus n is n plus 1 divided by minus n. For this is for n less than 0. If n equal to 0, gamma of n is 0, which is 1 factor, that is 1. Okay. So we need to use this formula to make this minus 3 by 2 as gamma of 1 by 2 and then substitute square root of pi. So how do you do that? So minus 3 by 2 we have, it will become minus 3 by 2 plus 1 divided by minus 3 by 2, which will be, if this goes to numerator, it will be minus 2 by 3, and this will be gamma of minus 1 by 2. Again we have minus here, so minus 1 by 2 is minus 1 by 2 plus 1 gamma by minus 1 by 2. N plus 1 by minus 1. Wherever n is there, I am substituting minus 1 by 2. So this will be, if it goes to numerator, it will be minus 2 gamma of minus 1 by 2 plus 1 is 1 by 2. So finally we have got gamma of 1 by 2. If you have gamma of 1 by 2, you have to substitute this minus 2 as it is square root of pi. So gamma of minus 1 by 2 is minus 2 square root of pi. Gamma of minus 3 by 2 has minus 1 by 2 here, gamma of minus 1 by 2. So substituting gamma of minus 1 by 2 here, minus into minus plus, 2 by 3 into 2 is 4 by 3 square root of pi. Okay, so this is the gamma of minus 3 by 2 value. Okay, so you have to remember these two formulas and this one value. Okay, so gamma of 1 by 2 square root of pi, and use this formula to evaluate this. So what will I get now? F of s is gamma of minus 3 by 2 is 4 by 3 square root of pi, and s power minus 3 by 2 in the denominator. If it comes to numerator, the sign changes, so it will be s power plus 3 by 2 in the numerator, and you have to replace s with s plus 4 here. So you will get so the Laplace transform of whatever the given function is equals to 4 by 3 square root of pi s plus 4 3 by 2 power 3 by 2. So this is the Laplace transform of this function, which you have to use properties, and finding t power n, if n is fraction and negative, we have to use gamma function, and then replace s with s minus a. In this case a is minus 4, so we have to replace s with s plus 4. Okay, let's see another question. So the simplest way to improve your CGPA is by studying the previous year question papers, and this works for all branches, any subjects, and for engineering math subjects, especially for M3, we have prepared an e-book, solutions to previous year question papers and model papers, that I think will help you enormously. Okay, I will leave the link to the e-book in the description. Please go check out our e-book. And if you are somebody who don't want to take any chances and prepare thoroughly for the examination, and if you are somebody who needs help understanding the solutions that are written in the book, you can check out our course, which is amazing and self-paced and very affordable. And I will leave the link to the course in the description. Please go check out our course.